Want to learn how to install FreeBSD, including the desktop environment? Stay tuned to see the step-by-step installation process. You can install any desktop. In this video, we will install XFCE because it is lightweight for a simple but refined user interface. We enter the official website. It shows the main features of native ZFS, virtualization with bhyve, and isolation using jails. We choose AMD 64 and select FreeBSD 15.1 release disk 1. We download the image and copy it to a Ventoy USB. Since the last version, booting FreeBSD is supported, but you can select any image burner. We wait for the process to finish. It enters directly into the installer. Press Install, select the keyboard layout. In my case, I use the Latin American version. It asks for the hostname. I enter FreeBSD. Then we select Tech Preview, because it will be the new standard for package management. Now press Network to configure the Internet. Select the appropriate network adapter and enable the automatic configuration. ZFS is the strongest technology, but for old computers, it is preferred to use UFS. Then we select the entire disk. We press Yes, then select GPT for the partition table. If UEFI is not available, you can select MBR for the system partitions. We press Finish and Commit. It will perform the partitioning and formatting process of the file system chosen in the previous step. It asks us about the packages we want to install. By default, it includes the system base, kernel, and libs, but more can be added. Now the copying of the base system will start. At the end, it asks us to enter the root password and its confirmation. Press OK. Then it will ask for the time zone. We select our country. In my case, Guatemala. It asks if we want to use DST, then date and time. Under boot services, SSH allows remote access, NTP syncs the time, and Powered optimizes energy. I will keep defaults. I leave the default security options. Options like hide IPC, hide jails, proc debug, clear TMP, and secure console also appear. The firmware installation for the Intel Kmod GPU appears enabled. We leave it as it is and wait for it to perform the configuration. We press Yes to add a user. We enter the username, the name, the default UID, then we leave the user as the primary login group. It asks if we want to add groups. We enter wheel, video, operator, and network. We leave the default login class as SH. We leave the default directory, same for permissions. We accept authentication without an empty or random password. Enter password. And its confirmation, we see the summary and confirm. It is fine. After adding the user, it asks if we want more. We enter No. We have completed the configuration. Click Finish, then select that we do not want manual modifications and reboot the computer. The system boots for the first time. We enter the root password. We update, executing the commands pkg update and pkg upgrade. We install packages, Nano Editor, Xorg Display Server, XFCE Desktop Environment, Firefox Browser, and Fastfetch, Sysbench Tester, LightDM Display Manager, and its GTK library and DRM Kmod to install graphics drivers automatically. Then it will begin installing the mentioned packages. This process on a 6th generation computer takes around 20 minutes. We run with sudo and uncomment the wheel all line. Then we press escape the letter W to write and Q to exit. We edit the rc.conf services file with nano. Add the line dpos enable equals yes at the end to enable inter-process communication. Although it is no longer necessary, we will also add the hold enable equals yes line for detection. Then we enable the session manager. We enable LightDM by adding the LightDM enable equals yes line. Only the video driver would be missing. Save the rc.conf file and exit. With the pcconf command, we can observe different PCI devices. We mainly look for the Intel one to add the KMS configuration. We edit RC again, add KLD list 915KMS for modern hardware. That is why we show it. Save the file and exit. We run the reboot command for the changes to take effect according to the documentation. We wait for the system to load as root. We test the startx command, but my PC is not supported by KMS, so we edit RC again to completely remove KLD list. We install the reliable XF86 Video Intel package. This package is the open source module for the X Windows System graphics drivers. For this module to work, we must configure the monitor. We verify that the xorg-confd directory exists to save the config there. In this case, it is not created. We create it with mkdir, then edit the 10monitor.conf file inside the xorg-conf folder. In the file, we add the device section, the card0 identifier, and the VESA driver. Finish the section, save the file, and exit. We test the startx command and see that it now works and the window manager opens, but we want to use XFCE as a user. We close it. With the exit command, we leave the root session. It will ask for the login again. In this case, we enter the user credentials. We run echo with exec and start xf4 for the xinit.rc file. Then we try running the startx command again to confirm. For my computer, this is the way to install and configure XFCE. Now we can leave the desktop environment to restart the machine. The system boots, then we see LightDM Session Manager, we enter credentials, and it will directly enter the desktop environment. We do a review of the desktop panel and menu. We see that it brings the default applications of the desktop environment installed. Right-clicking on the desktop opens a menu with desktop options, mainly settings. Then we open the system terminal emulator. Inside the terminal, we can run Fastfetch to see the system information, mainly the kernel, environment, memory, and disk usage. FreeBSD is a very good alternative to Linux, mainly because it is an OS and not a Linux distro, but it still needs a few refinements. This has been all for this video. If you liked it, subscribe, leave a like, and activate notifications. See you in the next video.